Our Carolina Bay survey is being effected with overlays using Google Earth. Each overlay can capture metrics on the bay. Placing the overlays is a manual process. What I'm going to demonstrate here is working in the Sumter USGS 100K quad in one of our octants there, which you see on the screen here, which is octant 134321. We've already identified some bays shown by the balloons, and I'm going to be adding some more. The process continues by us copying a current bay and placing it, pasting it back in again, and then editing that bay by doing a get info on it. That highlights the bay, and then we're in a position to rotate that in and place it. Our LiDAR overlays are set up such that they'll drop out at about 3 kilometers eye altitude, so after setting it in the LiDAR imagery, we can drop down to the actual satellite photography and see how well that fits. And this one's a pretty good fit. Copy paste another one of those, and we'll move it to this smaller one over here. Now we resize by using the corners, and then it's also possible, of course, to rotate that overlay if we feel that the rotation isn't quite correct. Now you'll notice when you roll in on the satellite view that you do get a different view. The white area around the bay is typically the rim, and in this case there's probably some paths on the rim here, whereas the dark areas in the LiDAR are actually the flat bottom of the bay, as the dark areas of the satellite imagery often is, although in this case there's a lot of trees in this area here. Now we can quite often find the bays and just lay them in using the satellite view, but in this case we'll continue doing adding overlays starting with the LiDAR view. Now we can see this bay here does require a rotation to make it look effective, and then if we drop into the satellite view we can see it does fit into an area of trees. I'll do another one. We'll go down to this one slightly below here. We'll line it up so that the white area of the overlay is kind of along the edge of the rim and outside of the floor of the bay a bit. Then we zoom in on it and we can see that it does fit pretty well with what's there on the ground. Now I mentioned we can also continue by just simply working with the satellite view, and in a lot of cases where we don't have good LiDAR imagery, the satellite view is the only tool we have, and we can see here it's pretty practical just simply to put the overlay on the satellite view and looking at the hints involved, the rim here, the rim over on this side, to map this overlay onto the bay. Then as we back out, of course, we'll see how well that fits with the LiDAR imagery, and again you can see it's a pretty good fit. We'll do another one. We'll move up here to one of the smaller bays, and then we'll just drop it on there. The alignment stays pretty correct, and we drop in and look at it, and you can see that in the wet areas, which are darker, are not necessarily not necessarily map well with the actual rim of the depression as seen in the LiDAR. The rim, if it's available in LiDAR, will be used by the survey to properly describe the depression. Continue back over here. I'm using keyboard shortcuts Control V, Control C, and Control V to do a copy, and a Control I to do the get info or properties as it is on a PC. and we'll make one here from the view on the satellite imagery, and then back out to see how well that maps in, and typically it does map in quite well. It's very satisfying mapping here. Now there's obviously a depression right here. You can see it on the LiDAR. It's probably only a few centimeters, maybe 10 or 20 centimeters of depression. And if we zoom on the land, we do see that there is a wet spot here in the soil, although it doesn't really help us map this depression, and we will require to do it with the LiDAR. Similarly, this item over here. Unfortunately, there actually is a slight alignment challenge with Google Earth. These overlays are created for LiDAR, are created outside of Google Earth, imported as KML and laid on here as overlays. And as such, they're subject to slight distortion in their orientation and their alignment. So there are times we do see a few meters of misalignment between the LiDAR and the ground survey and the satellite photography. Obviously the question would be which is correct, the satellite photography or this overlay. But in either case, there's usually not that much of a difference to the position, and our actual geographic position of these overlays is not terribly critical. What's critical in our survey is capturing the orientation of the bay, as shown by the arrow in this overlay, as well as the length and breadth of the bay. So we can calculate a ellipsoidal size, the eccentricity of the bay, as well as simply the simple aerial extent of the bay, which we measure in hectares. Now you can see this process here is quite easy to accomplish with the copy-paste. We have another mechanism where we can just put place marks on these and create, using our calculator, create the overlays. But once you get rolling here, this is usually the fastest way to capture the metrics of a large number of bays. In one of these octants, we've gotten upwards of 900 bays identified in some locales, and this particular one wouldn't surprise me if we came up with close to 1,000 bays here also, simply because the density is so high, and augmented by the fact that we do have this very good LiDAR imagery. Now here's an example of where there's actually clearly a depression in the LiDAR, and nothing shows up on the ground at all. That's plausible. Obviously, it's been farmed. It's been you can obviously see from the lines in this treed area that this is probably a plantation of trees, so they've been placed there by man, and often this work done on the land here for farming, being done for a couple hundred years, can destroy the bays. But it's very hard, and we see it even in urban settings, to actually destroy this elevation change that's represented by the basin formed when the bay was created.